So in this case, 1/2 and 1/3. If we were using money, what's half of a dollar? 50 cents. What's 1/3 of a dollar? Katie? Oh, her hand came down suddenly. Because she's thinking. What's 1/3 of a dollar?
30 cents?
Nope.
33.3.
Yes, the 33.333333. It doesn't work out equally. So we can't use the money model for this. But that's why we're introduced to the clock fractions yesterday that we had. So if we use the clock fractions and think about it, if we shaded in the first fraction, what would that look like? How much should I shade in? Hallie? Half of it, because it's a half fraction. And you can shade the whole thing in with your pencil. I'm just going to lightly scribble mine in with my pen. And then if we shade in 1/3 of the clock, should look something like this, because what number fits into 63 times? What number fits into 63 times? 20, very good. 20 minutes, 1/3 of the clock. And now we can combine these two to get a new fraction. So if we look at this, remember our clock is divided automatically into how many parts? How many parts? 12 parts. So if we shade in 1/2 like we did with our first fraction, and then shade in 1/3. Now we're shading in 1/3 of the clock. 1/3 is how many minutes? 1/3 is how many minutes? 20 minutes. So then I shade in 20. And now if we shade in the whole thing lightly so you can still see it, what does that equal? What does that equal all together? If we add 1/2 and 1/3, how much is it?
60 minutes. Right?
How much? What fraction?
I know it. I'm not 60 minutes. I know it.
These are all divided into 12ths, and I've shaded in all of these. What's our whole fraction? 5/6 is one option. Can you explain why it's 5/6, Clara?
Because 1/2 is 3/6.
1, 2, 3/6. Yep.
And then 1/3 is 2.
1, 2, and 3 and 2 is 5/6. So that's one reason it's 5/6. Could it be something else, Chase?
10/12.
It could be 10/12. Can you explain why?
Because there's 12 of the little marks.
Yep, we got 12 marks.
And 10 of them are shaded in.
Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10/12. So we could put 5/6 or 10/12. Could we put anything else? Could it equal anything else? 50/60. Could you explain that?
Because there's 60 minutes and it's taking up 50 of them.
Yeah, there's 60 whole minutes and we shaded in 50 of them. So we can say that 1/2 plus 1/3 equals either of these. They're all the same. Each one of these fractions represents the same space. Revel?
Could you do 2024?
20, 20 what? How so?
Oh, I see. Because if you split the pizza or whatever
The clock? Yeah.
to half or in the middle of every line.
So if we split these, you mean?
Yeah,
If we split the 12ths?
yeah.
And you said what fraction?
24. No, 10, 20, 24.
20, 24. So let's see. Now, if we have this fraction and they're both even, that means we have to do what to it? Always. If they're both even, we always have to do what?
Find an equivalent fraction.
Reduce it. We always have to reduce it. What divides into 20 that also divides into 24? What's the greatest common factor for those two numbers? Revel? 4. 20 divided by 4 is? 5. And 24 divided by 4 is? 5/6. See that anywhere? Yep. Very good, Rev. So any of these, that's a good job, Rev. 50/60ths, 10/12ths, and 5/6 are all equivalent. They all show the same amount on this clock. If these were pizzas, and you thought pizzas were okay, but not so great, but you'll eat it, which would you rather have a slice from? You don't love it, but you don't hate it. Which one did you rather have a slice from, Cara?
5/6.
Why would you want one from 5/6?
Because it's not the biggest out of those two.
Okay, I understand what you're thinking,
Oh, wait.
but remember, these are all equivalent. But which one would you rather have a piece of pizza from if pizza's so-so? Elian?
5/6 because
But you don't love pizza, it's just so-so. Why would you want one from 5/6?
so I don't have like 50 slices of pizza, so I can just eat like 5 big pieces.
But you only get one slice. So then I would want one from this then, if with that logic. I understand what you're saying. Pizza's so-so. Take it or leave it. Trevor?
I would, well, if I didn't like it, I would also choose 50/60th.
No, not if you don't like it. You have to eat it. You don't hate it. You don't love it. Maybe my question isn't the greatest. Clara, you're picking up what I'm saying, right?
I would do 10/12 because you get like a medium-sized piece, not an itty-bitty piece, and not
Right.
this big.
Yeah, these pieces are going to be the smallest. These are going to be the largest because there's only a pizza cut into 6 slices. So the pieces are going to be largest. These are going to be right in the middle. So. My question probably wasn't the greatest. But if you love pizza, which would you rather have one from? 5/6, because we got the largest slices. Don't like pizza? You want a tiny slice. Very good. What else can we say 5/6 is? How many minutes? How many minutes?
50 minutes?
50 minutes. Good. All right, here's the next one. You already might have seen it down there. 1/3, 1/4. I'm going to do it on this one. 1/3 plus 1/4. What's 1/3 of a dollar?
33.3333.
Yeah. Doesn't work out equally. That's why we can't use the money model. 1/4 of a dollar, we could, but we can't. So let's shade in 1/3. How many minutes are we going to shade in for 1/3? 1/3 of a clock is how many minutes? 20 minutes. Good, Dom. So there's my third. Then we'll shade in. What's a 4th going to look like? A 4th of a clock is how many minutes? Cole? 15 minutes. And now on our final one, we're going to combine them. So first we'll shade in our 20 minutes. Then shade in our 15. Now here you got to be careful. Where's your line going to go for 15 minutes? Someone want to go up and point to where our line's going to go? Where will our line go? Because it didn't work out quite the way we wanted to. Katie, where will our line go? You want to point to it or come up here even and draw the line? Come up and draw the line. It's probably easier. See if you can draw where our line will go for 15 minutes. Very good. 15 minutes. 5, 10, 15. Now, if we look at this clock, what's our answer? 1/3 plus 1/4. Sometimes you have to only use certain fractions. So what's the answer going to be to this one? If you want to make your divisions more clear so you can see where the 5-minute chunks are, what's our answer going to be? Zach? 45/60ths, because that's 45 minutes out of 60 minutes. That's one answer. What else? We want a smaller answer, though. Remember? Otherwise, we got to keep reducing and reducing and reducing. What's our answer going to be? What's the 3rd and the 4th? What'd you shade in? What fraction of the clock? Who sees it? Chase?
Wait.
Take your time. What were you thinking?
7/12.
7/12ths. And how'd you get that, Chase? Come up here and show us how you get 7/12ths. Use our marker there. Point, draw, whatever you want. How do you get 7/12 there?
By minusing 5 from 12,
Oh, so the 5 that we didn't shade in.
7
Okay, good.
here.
Is that the only way to figure out that it's 7/12? That's a great way to do it, Revel. How would you do it?
Just count the pizza and clock.
Count the shaded areas, right? We shaded in 1, 2, 3, 4, 5, 6, 7 of the 12ths. Is that the only answer? Are these the only answers? Which answer's better? Oh, Chase?
No.
Could we do what Revel did and divide it up further?
Yeah.
Because right now, he divided 45/60ths. We could divide these up again like Revel said, and then what would our answer be? Yep.
Well, I don't have an answer.
Oh,
I'm saying I don't think 45/60 is gonna work
why?
because on a clock, if it's like 10:45 or something, it goes straight this way.
Mm-hmm. So it's not 45 minutes, is it? What would it be? Not 45/60ths, but how many 60ths? Cole?
35.
35/60ths. Good observation. So 45 would have been over here. We got 35. So back to this question, what if we divided each of those up? Then what would our answer be? There's 7 of them. We divided them into 2.
14/24.
14/24. So minus this one, all 3 of these fractions are what? They're all equivalent. They are all showing the same amount of space on this clock. The clock's just divided up differently. One more. This one's a doozy. I'm just kidding. It's like every other one. What's the 1/6 of a dollar? Could we use the money model for 1/6? We could? Yes or no?
No.
No, we haven't mentioned a 1/6 of a dollar ever because there isn't a 1/6 of a dollar. It'd be an odd number. Would 3/4 work? Yeah, that'd be 75 cents. But since we can't, let's use our clocks. So I'll shade in 1/6 of the clock. Remember, it's divided into 12 parts. It's divided into all those other sets. Sets of 5, sets of 10, sets of 15, sets of 20, and sets of 30. How many minutes is going to be 1/6? Which of those numbers fits into 60 6 times? How many minutes, Chase?
10.
10 minutes. So here's a 1/6. Very good. There's a 1/6 of a clock. Plus 3/4 of our clock. What would 3/4 look like? Someone come up and show us 3/4. Draw, shade that in. Rev, come on up. Show us where 3/4 would be on the next one. Did you get your nails done? You look beautiful.
What?
No, just kidding. 3/4. Good. Oh, let's compare a young hand to an old hand. Put your hand out. Ugh, look at that. That's what you're going to look like. All right, now let's take a look. See what we come up with. What is a 1/6 and 3/4? So on your third clock, shade in your 1/6, then shade in 3/4. Now when your clock is like this, you can't just put it over here because that's not right. So you have to know how many minutes this is or how many 12ths it is. How many minutes are you going to shade in over here so it's 3/4? Or how many 12ths would you do? Chase, you want to come up? You already are up. Who else can come up here? Clara, show us where or how to shade in our 3/4. So if you look at your second one, how many 12ths is that? Just shade in that many here. Go right ahead, kid. Where is it going to be? And show us what you did. You can count out loud, do whatever you need to. Interesting. So what's what here?
So
That's 3. Okay.
this one is 1/6, and then this one's 3/4.
So you shaded in how many of what? What'd you shade in? How'd you look at it?
Well, I looked at it as just like putting them next to each other
Okay.
and then having a little piece.
All right, cool. Very good. So if we add that together now, what's our answer? What's our answer? We know it's a clock, so it's going to be pretty simple. Cole? 11 twelfths. That's the simplest answer to get, because we know the clock's into 12 parts. There's one empty one, so that'd be 11 twelfths. That's the simplest way to do it. Could it be anything else, Cole? 55 60th, because we got 55 minutes out of 60 minutes. Very good. Could it be anything else? 20 who to what to where? 22 24ths. How so?
As if you split them all in half.
Split the, oh, you mean double them?
Yeah.
Technically, we're doubling, right? We're splitting them, which doubles the numerator and the denominator. So it's 22 24ths. What would be after that? What if we doubled that? Then what would it be? 44 48. So we can just keep on cutting those slices smaller and smaller and smaller. Could it be anything else? Does anything else work out equally?
Wait.
Okay.
88.
Oh, you're going on this one?
Yeah.
88 what?
88,
Help them out, someone. 88,
96.
96. Yep. What about anything else that we're more familiar with? We got the twelfths. Could we do sixths? No, because a sixth would take it up, right, Carson? So very good. So all these, 1, 2, 3, 4, 5, each of these fractions are what? They're equivalent. They're all showing this. As hard as that is for some of you to understand, you got to trust us. You love pizza? Trevor, do you like pizza? No? Okay, so which would you rather have a slice from? This one or this one?
11, 12.
You would, but you don't like pizza? You're a trooper. If I didn't like it, I'd want one from this one. Why?
Because they're smaller slices.
Can barely see this slice. Need a magnifying glass. But Ella loves pizza, so she'd want one from here because the slices are what?
Big.
Larger than that. I mean, are they huge? No. The average pizza is cut into eighths, so it's still going to be small, but it's going to be bigger than that. Can you imagine how small that slice would be? That'd be like
I can't imagine.
it'd be like cutting up one of the birthday cookie cakes that we have to cut up for you guys.
It would be like this.